Hello. In this video, we're going to look at sketching angles. Now to warm up, we might be asked to sketch the angle 100 degrees, and this isn't too challenging. I generally recommend we throw down a little XY axis. We want to start our angle right here on the positive X axis, and then we rotate counterclockwise 100 degrees, which looks just a little bit more than 90. We draw the end, and we label 100 degrees. But what about something like 1,000 degrees? Well, again, we could start with a little XY axis, but if we were to sketch anything more than 360, we're going to go all the way around, right? Something like this would be 270 degrees. And if we went all the way around, we'd have 360 degrees. So how do we sketch 1,000 degrees? And what we have to do is we have to think about how many groups of 360 might have gone into 1,000. So for example, if we subtract a group of 360, well, that's going to give us 640 degrees. But we could subtract another 360, and that's going to give us 280 degrees. Now we can't subtract any more 360s because if we did, we'd make it negative. And so what we want to do is we want to think about the angle 280. Where is that? Well, again, 270 we said would be down here, so a little bit more than that, maybe right there. And so this angle would be 280, but we need to emphasize that we've gone around 2 times. So we draw something like this where we have 1 revolution, 2 revolutions, and then around to the angle. This represents 1,000 degrees. First a revolution, then a second revolution, and then ending up at 280. Now this number 280, this final thing, the part we sketch, not the spiral part, it's important and it has a name. This is called the principal angle. And this principal angle represents the final, or the correct, or the angle that you would actually draw. We always want to have the principal angle between 0 and 360. So if you have an angle bigger than 360, you have to keep subtracting until you get to 360. Or if you have an angle smaller, you have to add, because your final answer should be somewhere between 0 and 360. Let's look at another example. Say we have the angle 2,550. How would we sketch something like this? Well, again, we would want to subtract off groups of 360. So you'd subtract off 1 or 2 or maybe 3 360s, and you would just keep subtracting. In fact, if you were to look at it carefully, you'd find that 7 groups of 360 would be equal to 2,520 degrees. So you could subtract not just 1 or 2 360s, you could actually subtract a total of 7 360s. So that's going to give us, if we subtract 2,520, a final angle of 30. So that final angle is called the principal angle. And so when we go on our little XY axis, we draw the principal angle, something like 30 degrees. But then we reference the fact that there's 7 revolutions. So that's drawn, which is going to be a little bit crazy here, something like this: 1, 2, 3, 4, 5, 6, 7, and then to the 30. Now, on a quiz, you probably wouldn't get more than maybe 3 or 4 revolutions, because it gets a little tricky to draw all 7 revolutions. I didn't do the best job here, but you get the idea. Now what about something like negative 400? Well, in this case, we have to add 360 because we have a number that's less than 0. If we add 360, we get negative 40, which isn't quite positive. So we got to add another 360, and that's going to give us, well, 320. So that means that to get to 400 as a negative, It's almost like you had to go around and then around again. But this one's a little bit tricky, so let's be careful here as we sketch it. The negative ones are a little bit dicey. If I was to start here, this would be negative 90. This would be negative 180. And all the way backwards once, that would be negative 360. So to get to negative 400, I need to draw that angle of 320, which is going to be roughly here. But I only go backwards one time and then straight to the angle. This is negative 400. Even though in my math I added 360 twice, I only actually go around backwards one time. So I know it's a little quirk of the math there. Now let's look at sketching an angle that's in maybe radians. How would you do something like this? Well, you're welcome to convert it to degrees if you want, but I would recommend trying to think about it in terms of radians. Again, if we had our little XY axis, we could think of something like this. If this was our angle, this would be pi radians. If we went maybe to here, this would be 3 pi over 2 radians. And if we went all the way around to here, this would be 2 pi radians. And so how much is 17 pi over 3? Just like before, we need to subtract off copies of 2 pi to get the principal angle. Now we have to do some fraction work here. So this is going to be 17 pi over 3 minus 6 pi over 3. That's 11 pi over 3. Oh, that's not quite there. We need to get a number between 0 and 2 pi. So our principal angle should somewhere be between 0 and 2 pi. And in this case, 2 pi, if we write it as a fraction, is 6 pi over 3. 11 is more than 6. So we got to subtract again. Let's minus off another 2 pi or another 6 pi over 3. That's going to give us 5 pi over 3. All right, that's the angle I'm looking for. Let's go ahead and sketch the principal angle. This is again our principal angle. Let's sketch that, and then let's include the 2 revolutions. So 1, 2, and then my principal angle. This would represent 17 pi over 3. Now I want to give you some tough ones to think about. For example, let's say we had the angle 123,456. I don't want you to sketch this, but I do want you to tell me the principal angle and how many rotations it takes to get to that angle. Go ahead and pause the video and see if you can come up with an answer. All right, hopefully you stumbled upon the idea of doing some division. You need to subtract off groups of 360, but you're going to be here all day if you keep subtracting 360. You need to find out how many times 360 goes into 123,456. So if we divide it by 360, we find out that we get 342 revolutions. So that means there are 342 groups of 360. So we can take 360 times 342, and that's going to tell us how much we should subtract off of our angle. That's 123,120. So we can take our original angle, we can subtract off a bunch of 360s, and that's going to give us our final principal angle. In this case, 336 degrees. So how many revolutions? 342. And what's the principal angle? 336. Let's take a look at another question here. How many rotations and what is the principal angle for 437.24 radians? Ooh, this one's a bit of a doozy. I'll let you pause the video and give it a try. All right, what makes this question so difficult is that you don't have a pi. The pi has been multiplied in, that's why we have, unfortunately, a decimal number here. So we still have to subtract off groups of 2 pi, but we don't know how many, and so we're going to try the same approach as before. 437.24 divided by 2 pi, and that's going to give us, well, when you look at the answer, it's 69 with some decimals, which means we have 69 revolutions, or 69 full rotations. Okay, so that means it rotated 69 times. So we can go back and we can figure out 69 times 2 pi. Well, using a calculator, 69 times 2 times pi is going to give us, let me just see here, 433.54. So if we subtract that, 437.24 minus 433.54, that's going to give us 3.7 radians. And so again, what's the principal angle? This right here. The final answer you get. And in radians, it should be between 0. It should be between 0 and 2 pi. Or if you're thinking in decimals, it should be between 0 and 6.28. And in this case, 3.7 is definitely in that range. So we found the principal angle, and we found the number of revolutions, and we didn't have to convert to degrees. Now just a couple last problems for you to think about. Try sketching the angle 2.95 radians. I'll give you a chance to pause the video and give this a try. All right, again, this is a little nasty because it doesn't have any pi in the answer. And if you wanted to convert to degrees, you could certainly try that. But I'll show you another way of thinking about it. Again, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. Those are the nice values if you leave them with the pi. But you don't have to leave them with the pi. And if you're using a calculator, pi over 2 is approximately 1.57. Pi is approximately 3.14. And 3 pi over 2 is approximately, let me see here, 3 pi over 2, 4.71. So the number 2.95 is really close to 3.14. So I would expect it to be somewhere like there. This would be 2.95 radians. And like I said, we could convert it to degrees just to check. We could put the 2 pi radians on the top and the 360 degrees on the bottom. 2.95 radians on the top and x degrees on the bottom. We cross multiply to get x equals 2.95 times 360 divided by 2 pi. Now we go ahead and grab a calculator, and that gives us 169.02 degrees, which looks close to 180, just a little bit before, which is what we drew on the XY axis there. So again, one last question for you to think about. How would you sketch the angle 4 plus pi radians? Go ahead and pause the video, give it a try, see what you come up with. All right, so hopefully you gave this one a try. What we definitely want to do is calculate a quick decimal version here. Again, pi is 3.14, so this is about 7.14, which means it's outside of the 0 to 2 pi. We got to subtract. We have to subtract off a 2 pi if we want to have any chance of sketching this, because we need to know that principal angle. Now, if we're going to do it exactly, 4 plus pi minus 2 pi on a calculator is going to give the following. 0.8 0.58. So it means that we started here, we went around one whole time, and we ended up at 0.8. Well, again, where is 0.8? It's kind of strange. And you could convert to degrees, but if we remember, this is about 1.57, and this is 0. So 0.8 is probably about halfway. Sketch it right there. Show the 1 revolution, and then go straight to your answer. There's 4 plus pi radians. All right, you should be good to go to try the worksheet now. Hopefully you enjoyed this video. Thanks for watching.